Hi, this is Eddie, and in this video we're going to find a quadratic equation y equals to a naught plus a1 times x plus a2 times x squared that contains 3 points on the Cartesian plane. We'll label the 3 points x1, y1, x2, y2, and x3, y3. How are we going to do this? We're going to use some linear algebra. To find a naught, a1, and a2, we're going to calculate the a vector. The a vector is going to consist of the coefficients, and it's going to be equal to the inverse of matrix V times the y vector. The y vector is just the y coordinates, y1, y2, and y3. V is a Vandermonde matrix. The Vandermonde matrix V is going to be of size 3 rows times 3 columns. For each row is going to have 3 elements. The first one's going to be 1, x1, x1 squared. The middle row is going to have 1, x2, x2 squared. And the last row is going to be 1, x3, x3 squared. You're going to be taking the inverse of this and multiplying by the y vector to get your final answer. For example, I would like to fit a quadratic equation to these 3 points: -1, 3, 0, 2, and 3, 5. I like to start out problems of this type by listing an xy coordinate table. Now I'm going to go in the order of increasing x. So I'm going to start off with -1, 3, 0, 2, and then 3, 5. From here you can build your y vector and your Vandermonde matrix. First, the y vector. You can easily see that this is going to become 3, 2, 5. If you go here to your Vandermonde matrix, which is going to be 3 by 3, and what I like to do as a note to myself is I'm going to label the columns 1, x, and x squared. So the first row is going to be 1, -1, -1 squared, which turns out to be +1. Then 1, 0, 0 squared, this is still 0. And finally 1 for the third row, and then x is 3 at this point, and then 3 squared is equal to 9. This is going to be my Vandermonde matrix right here. Now I have what I need to calculate the a vector, which is going to be a naught, a1, and a2, which is equal to v inverse y vector. And I'm going to use my calculator to determine the a vector. Okay, I've entered the Vandermonde matrix into my calculator, and then I'm going to take the inverse of this matrix right here, and then I'll multiply it by the y vector, which was 3 down to 2 and down to 5. And here I'm going to get my a matrix, which turns out to be 2, -1/2, and 1/2. So our polynomial of interest is going to be y equals 2 minus 1/2 x plus 1/2 x squared. And here is a graph of that equation, and as you can see, the 3 points, -1, 3, 0, 2, and 3, 5 fit perfectly on the equation y equals 2 minus 1/2 x plus 1/2 x squared. In summary, to fit 3 points exactly to a quadratic equation, you're going to need to let V be the Vandermonde matrix 3 by 3, each row containing 1, x, and x squared of that point, the y vector being the vector of y coordinates, and your calculated coefficient coordinates is going to be v inverse times the y vector. My blog, Eddie's Math and Calculator blog, is at edspie31415.blogspot.com. Thank you very much and have a great day.